Module 2, Lesson 14, Modeling Relationships with a Line. Let's see, today we're going to determine the best fit line from a set of data, and we're going to use the best fit line to make predictions about other data points. If you have not done so already, open your book to page 83. Okay, example 1, using a line to describe a relationship. Kendra likes to watch crime scene investigation shows on television. She watched a show where the investigators used a shoe print to help identify a suspect in the case. She questioned how it's possible to predict someone's height from his shoe print. To investigate, she collected data on shoe lengths in inches and heights from 10 adult men. Her data appears in the table and scatter plot below. So these are 10 men and their shoe lengths and heights. You should be starting to look at scatter plots now and asking yourself, is there a relationship? Does it appear to be linear? Questions such like that. So question number 1 says, is there a relationship between the shoe length and height? Immediately when I look at it, I look at it and say, yes, it looks like the points tend to go in a positive direction. So I'm looking at it and I'm saying yes, as the shoe length increases or gets bigger, the height gets taller. You would typically think that would be true, that a person with bigger feet is going to be taller. Is it 100% true? No. But that's why the points are scattered. Most of the time it's true. And how would you describe the relationship? Do men with longer shoes tend to be taller? So I would describe it as a positive relationship. And yes, I would think that, I would say men with longer shoe lengths are taller, or tend to be taller. So it's a positive relationship. Yes, men with longer shoes tend to be taller. Okay, example 2, using models to make predictions. When two variables, x and y, are linearly related, you can use the line to describe the relationship. You can also use the equation of the line to predict the value of y based on the value of x. For example, the line y equals 25.3 plus 3.66x might be used to describe the relationship between the shoe lengths and the heights. Where x represents the shoe length. Okay, so x is the shoe length and y is the height. To predict the height of a man with a shoe length of 12 inches, you would substitute 12 for x in the equation of the line and then calculate the y value. They did that for us right here. So a man with a shoe size of 12, we're predicting that he's going to come out to be 69 inches tall. Right, that's what that was saying. Okay, exercises 3 through 7. Below is a scatter plot of the data with two linear models. Y equals 130 minus 5x and y equals 25.3 plus 3.66x. Which of these two models does a better job of describing the shoe length and height? Explain your choice. Okay, so we have our first line, y equals 130 minus 5x, and that would be this line right here. And then we have our second line, the blue line. Take the blue here. Okay, so this is our blue line right here. Y equals 25.3 plus 3.66x. And they're asking us which one do we think would be a better fit to that scatter plot. Some people would say that it's the y equals 130 minus 5x, because it goes through 2 points. However, a lot of the time the best fit line does not go through 2 points. A lot of times the line just goes through the center of the points and doesn't actually hit any of the points at all. When we do the work, we usually make it go through 2 points on purpose, just so that we can use those 2 points to find the slope. Okay, so one thing I'm going to say about this is don't be fooled by the fact that it goes through 2 points. Okay, what you have to be more careful about is this is the correct one. And the reason why this one is correct is a couple of reasons. One, that line goes through the center of the points. Room there. Play a little small. And then another reason that it's important to notice is not only does it go through the center of the points, number two, we said that the points look like they're going in a positive direction, and you'll notice that that equation has a positive slope. Remember, where you find the slope is with the x. So in this case, the slope is 3.66, which in this case, the slope is -5. That's a negative slope. But those points are definitely going in a positive direction, so we want the positive slope. Okay, so again, don't be fooled by the line going through 2 points. They did that on purpose so that you would pick that one. Okay, one of the men in the sample has a shoe length of 11.8 inches and a height of 71 inches. Circle that point on the scatter plot. So he has 11.8, that would be a little bit past the 11.75, and a height of 71 inches. So if we look right here at 11.8, there's 2 points. Let me turn them into stars. There's this point right here and this point right here. Out of those 2 points, which one would be the 71 inches? It would be the top point. So they said circle it. So circle that point in the scatter plot in exercise 3 to represent that man. Okay, so I just did that. Okay, so done. Suppose that you do not know this man's height, but you do know that his shoe length is 11.8 inches. If you use the model y equals 25.3 plus 3.66x, what would you predict the height to be? So in other words, if we were to use the equation, let's go ahead and plug in the 11.8 and see what we get. Alright, so using my calculator, and I'm going to plug that in. So 25.3 plus 3.66 times 11.8. And I'm getting 68.488. So it's saying that that's how tall the guy would be, which we already knew that he was 71 inches, so that's a little off. And then it says, well, what if you use the model y equals 130 minus 5x? What would his height turn out to be? So let's go ahead and plug it into that equation. So 130 minus 5 times 11.8. That one's coming out to 71 inches. That one comes out exactly 71 inches. It says, which model was closer to the actual height of 71 inches? Is that model a better fit for the data? So the second one is more accurate for that particular man. Which is the first question. It says, which model is closer to the actual height of 71 inches, which it was the second model. And then it says, is that model a better fit to data? And I'd still say no. That doesn't make it better. It just happens to work for that guy. And the reason why it happened to work for that guy is because if we go up here, that guy's point happens to be the point, one of the 2 points that fell on that line. Okay, so is that model better fit for the data? No, because it has a negative slope. So the only reason why it worked for this particular guy, once again, is because that line happened to go through that guy's point. Okay, is there a better way to decide which of the 2 lines provides a better description of the relationship rather than just comparing the predicted value and actual value for one data point? Again, we'd want to look at the slope and make sure that the line is going through like the center of all of the points. So look at the, how about looking at the direction? That's what slope is. So I want to look at the direction of the line, whether it's positive or negative. And we want to make sure that it make sure the line is, let's say, roughly in the middle of the points. Okay. From there, you're going to skip over to page 87. Looking at example 4. We'll be coming back to the rest of the information, I believe, tomorrow. Okay, we're going to look at what we call the least squares line. This is exactly the same. It's just another term for the best fit line, which is what we've been talking about. The line that has the smaller sum of squared residuals, which is something that we're going to be talking about tomorrow, for the data set than any other line is called the least squares line. Okay, this line is also known as the best fit line. That's what we've been talking about, the best fit line. It's also known as the regression line. Oh, all these words that mean the same thing. Okay, so for the shoe length and height data for the sample of men, the line is the least squares line. No other line would have a smaller sum of squared residuals. Okay, so this whole idea of residuals is something we're going to be talking about in a couple days. Or not a couple days, actually tomorrow. There are equations that can be used to calculate the value of the slope and the intercept of the least squares equation, or the line of best fit. But these formulas require a lot of tedious calculations. So we've so far been doing them by hand, and that gives us an estimate, and then we've also been using a graphing calculator. So it says, fortunately, the graphing calculator can be used to find the equation of the least squares line, or the line of best fit. And your calculator actually calls it the regression equation. All right, and I've already shown you how to do that. It says your teacher's going to show you how to do that using a graphing calculator, which I already showed you. So exercises 14 through 17, it says enter the shoe length and height data, and then use your graphing calculator to find the equation of the least squares equation, which we've already talked about how to do that. So I'm not going to go over it again right now. But the equation that you would get is y equals, whoops, I forgot to change the color. Go back to yellow. Y equals 25.3 plus 3.66x. And that's the slope and the y-intercept, and they've been rounded to the nearest hundredths. Okay, so assuming that the 10 men in the sample are representative adult men in general, what height would you predict for a man with a shoe size of 12.5 inches? What height would we predict for a man who has a shoe size of 11.9 inches? So in other words, let's use the equation and plug those numbers in. So for the man that has a shoe length of 12.5 inches, let's do that one first. I take my equation, 25.3 plus 3.66, and then plug in 12.5, and that'll predict for us how tall that guy would be. So I'm putting in 25.3 plus 3.66 times 12.5. And I got 71 approximately. I got 71.05. And that would be inches. So that's how tall a man would be with a shoe size of 12.5. And if a man has a shoe size of 11.9 inches, or shoe length, not really the size, it's the length of a shoe, then how tall would he be? I would take 25.3 plus 3.66 and multiply that by 11.9. Okay, so 25.3 plus 3.66 times 11.9. And that's coming out to 68 0.85 inches. So that's how tall he would be. Which 65 is about 5 foot 8 inches, 71 is about just under 6 foot. That would be 5 foot 11 inches. Okay, you do in the homework have to find, I think that was the last example. Remember right? Yes. Okay, you do in the homework have to get the equation. So let's just run through the graphing calculator steps real quick to get the equation. You can do it by hand, but it's faster obviously on the graphing calculator, which I taught you that last week. So on the graphing calculator real quick, the first thing you do is click Stat, and that takes you to where you're going to be putting the numbers in. You do Stat, and then Edit, which is number 1, or it'll already be highlighted, so Stat, Edit, Enter. And then put your put numbers in list 1, in list 2. Then you can go out of the list by quitting, which quit is equal to second and mode. Let's see, then you're going to go back into 4. Go back into Stat, but this time you want to go over to Calc. And then you're going to choose number 4. Which would be the one that says Lin Reg. AX plus B, where A and M are the same thing. That'll take it to your main screen, and you want to scroll down to calculate and push enter. And then that'll pop up your y equals ax plus b. And pop your equation. So that's going to be in homework today. You're going to be making the scatter plot. And then it says to get the equation. A couple times you have to do that. So the sooner you get to your homework, the better, so that you can use your graphing calculator. Otherwise, if you take this home, then you'll need to just do it by hand. Okay, so that's it for today's lesson.